So we're going to start off by doing some simultaneous equations by elimination, and then I will send you some work on Hegarty Maths to do with this video. You can submit your answers and then I will send you the answers.
Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're solving simultaneous equations by elimination, our second video on that topic. To start with, the first video introduced simultaneous equations and I showed you how to do it by solving that one. Please pause the video and double check you can solve that equation there before you do this video. Okay, the solution was x was 4 and y was 2, and this was the process called elimination, which I introduced in video 1 and skill 1. I'm going to move forward in this video by assuming you know those skills, and I'm just going to do 4 different examples. So let's get going straight away. Pause the video and try this one if you think you can. Step 1, label the equations 1 and 2. Step 2, look at the coefficients of x and y and see if any are the same. They are. We've got 1x is here and 1x here, so we're in a great position. What we can do is we can take equation 1 and subtract equation 2 from it. Why are we doing that? Because we've got the same amount of x's, if we subtract equation 2 from equation 1, it will eliminate those x's and we'd just be left with y's. Right, what will I get when I do that? 1x take away 1x is on purposefully 0. I picked it for that very reason. 3y take away 2y is simply 1y, and 11 take away 9 is going to equal 2. And oh my word, we solved and we got y is 2 already. Now we're not done. To solve a simultaneous, you've got to find x and y, so we need to substitute that back into one of these equations. It doesn't matter which one, but tell the examiner what you're doing. So substitute y is 2 into, let's just do equation 1, it really doesn't matter, and we'll state what we get. So we're going to get ourselves x, add 3 lots of 2, now because y is 2, so we're putting 2 in here instead of y, is equal to 11. And we can solve from there. That's x add 6 is 11 when I multiply out, and if I subtract 6 from both sides, I'm going to get myself that x is therefore equal to 5, and I'm done. So I have to state my final answer at the end. X was 5 and y was 2, and before you move on, double check it. 1x, 5 add 3 times 2, 3 times 2 6, 5 add 6, 11, yes. 5 add 2 times 2, which is 4, 5 add 4 is 9, yes. Put your little smiley face here, you've checked it, you know you're right. Okay, next one. Pause, have a go. Step 1, label equations 1 and 2. Step 2, look to see if the coefficients of x or y are the same. They are. I've got 2 y's here and 2 y's here. So I can, as I did before, take equation 1 and subtract equation 2, because that will eliminate this 2y and I'll just be left with x's. So let's draw our little column subtraction. 5x take away 1x is 4x. 2y take away 2y, I purposefully kept the coefficients the same and subtracted to eliminate them. And 16 take away 4 is actually 12. We're in a position here, we know how to solve. To undo the multiply by 4, divide both sides by 4, and I get my solution for x. X is therefore 3. Great stuff. I'm not done until I find y, so I'm going to use sub instead of the word substitute. Substitute x is 3 in, maybe this one's easier. Equation 2 is easier, there's less work to do. Equation 2. So I'm going to put in 3 where I see x here. So I'm going to write 3 add 2y is equal to 4, and I'm going to solve from that point onwards. How am I going to do that? I'll subtract 3 from both sides to remove that, and I'll get myself that 2y is equal to 1, and then I'm going to divide both sides by 2 to undo that multiply by 2, and I get myself that y is therefore equal to a half, and I found my solution. So x is 3 and y is a half. Before I move on, should check they work. 5 times 3, 15. 2 times a half is 1. 15 and 1, 16. Looking good. That would be 3. 2 times a half is 1. 3 add 1 is 4. Yes, done it. Smiley face to say I've checked it. Move on. Next one, pause the video, have a go. Okay, step 1, label them, as always. Step 2, look for similar coefficients. I've got them, happy days, there's a 3x there and a 3x there. So what I can do is I can subtract the equations like I've always done, because that would mean 3x take away 3x gives me no x's. The reason this is a tiny bit more difficult, I hope you can spot. Let me show you. 3x take away 3x, I've said there's no x. 5y take away negative y. That, you have to think of that as negative. And that's where students go wrong. So we're subtracting the equation, so 5y subtract negative y, which hopefully, subtracting a negative you know is like adding a positive, so that would be like 5y add y, which is 6y. That's where students go wrong. Make sure you're super careful when you're subtracting equations that might have negatives in it. And 21 take away 3 is equal to 18. So, to undo the multiply by 6, divide both sides by 6, and we get ourselves y is 3. Great job. Let's substitute in to find ourselves our x. The easiest equation to substitute in is this one, does less amounts of y. So sub y is 3 in equation 2. And what would we get? Well, we'd get ourselves 3x, take away y. Now y, we've said, is 3, so we're substituting in 3 there. 3x take away 3 is going to equal 3. And to solve that, we would add 3 to both sides, and we would get that 3x is therefore equal to 6, and we would divide both sides by 3 finally, and we would get that x is equal to 2. And we'd go over here and we'd state our answer, x is 2, y is 3, and before we moved on, we'd check it. 3 times 2, 6, 5 times 3, 15, 6 at 15, 21, yep, looking good. 3 times 2 is 6, 6, take away 3 is 3, yes, great job. Checked it, smiley face, move on. Next one, pause the video and have a go. Step 1, label the equations 1 and 2. Step 2, look to see if you've got similar coefficients or the same. 4 and 7 not the same? Yep, 3 and 3, great job. Okay, now we can subtract the equations. The reason this one's a tiny bit more difficult, you've got negatives here, so students are going to potentially make mistakes. Let's just be really careful with this, okay? We are going to subtract the top one from the second one, like that. Now you've just got to really be careful here to say it out loud. If you say it out loud, you won't make a mistake. 4x subtract 7x. I'll even write it for you. By the symmetry of subtraction is negative 3x. It's not 3x. We're taking 4x and we're subtracting more x's from it. So you've got to be really careful to make sure you get negative. 3y take away 3y. Well, that's nothing. We purposefully made sure we only subtracted once these were the same. Here's where students might make a mistake. Negative 5 subtract negative 11. Let's even write it down. Negative 5 subtract negative 11. Subtracting a negative is like adding a positive, so that's negative 5 add 11, which you can write the other way around by, because addition is commutative, you can say that's 11 add negative 5, which is like 11 take away 5, which is 6. Or you could count on the number line. If you're at negative 5 and you go 11 to the right, you get to positive 6. And there you go. That line there confuses a lot of students because of the negatives. You've just got to take your time. You've just got to be super careful. If it takes writing some workings on the side, do it, guys. Now, we're going to find x. We have to divide both sides, not by 3, but by negative 3, because we want to undo that multiplied by negative 3. And I get myself that x is therefore equal to positive 6 divided by negative 3, which is negative 2. We need to find y, so we're going to sub x is negative 2 in. It doesn't matter which equation, let's just do it in one. They look as hard as each other. And what would I get? Careful here now. 4. I'm going to put in negative 2 instead of x here. Bracket negative 2. Add 3y is equal to negative 5. 4 times negative 2 is negative 8. Plus 3y is equal to negative 5. I need to undo that negative 8 or subtract 8. So I'm going to add 8 to both sides to undo that. And I'm going to get myself that positive 3y. or we're just going to write that as 3y, is therefore equal to negative 5 plus 8. You're at negative 5 on the number line. You go right 8 places, you get to positive 3. Then I'm going to divide both sides by that 3, and I'm going to get y is 1. So my answer is x is negative 2 and y is 1. Before I move on, I better check. 4 times negative 2 is negative 8. 3 times 1 is 3. Negative 8 add 3 is negative 5. Great job. 7 times negative 2 is negative 14. 3 times 1 is 3. Negative 14 add 3 is negative 11. And I can put my smiley face and sigh of relief. I did a really tricky example. And that's it for this video. Thanks for watching.
So now I'm going to set you some questions based on this, and hopefully you'll be able to do them. If not, send me a message and I will do a video of my own.